Okay, the first problem I want to look at is a confidence interval problem. These are the hardest problems you'll see from the unit. They're also almost guaranteed to be on your diploma exam. Another thing with this unit, as with the last, that shows up a lot is you're not always told directly this is a confidence interval problem. So you're going to have to be able to recognize that off the bat. And because it's an A-B type problem, part A is actually not necessarily for confidence interval, but part B is. So first off, this is taken off an old diploma. It was a four questions on this source talking about earlobes. Funny enough, that one little blurb there with the 39% is all you need to answer the problem. A lot of the time, students think that they're not given enough information. So basically with the 39%, that's a yes or no question. It's a binomial experiment. And if you remember from lesson 6, you can approximate a binomial experiment on the normal curve. It's not going to follow it exactly, but it'll be pretty close. Okay? So we're going to actually make a binomial experiment into a normal distribution. So first off, it's asking for the mean and the standard deviation. Well, if you've got a binomial situation, to get the mean and standard deviation, you need to use your formulas. So first off, the mean is u, and it's n times p. So the mean then, n is the number of people or items you have in your data. We're told in the problem we have 8,748 people. And the percentage is going to be written as a decimal of 0.39. Okay? So I can calculate my mean, and that comes out to 3,411.72. So 3,411.72 people is the average. Okay? So I've now done the mean. Standard deviation, the equation for that is the square root of n times p times 1 minus p. So the standard deviation then, n is 8,748. It's the number of people. The probability of having the successful outcome is 0.39. 1 minus p is the complement of that. Well, if you go 1 minus 0.39, you're going to get 0.61. If I go through and calculate that out, remember, do the square root last. I get a standard deviation of 45.6196. Get in the habit of carrying as many decimal places as you can until you've done the question. Okay? So now that I have my mean and my standard deviation, I can move on to part B. Okay, so now on to part B. I've set up part B. This is something you need to be able to do yourself. In part B, it's asking for the 95% confidence interval. What a confidence interval is given the data, which we've drawn as to be on a normal distribution, we want to be 95% confident in the data. What that means is they want a data range. They want this point here and this point here. In this case, the number of people in which 95% of the data sits. So 3,411.72 is our average. What the question's asking for is what is the data value here and here that has 95% of the data between it. The funny thing is the 95% isn't directly what we're going to use. What we are going to use is the fact that if there's 95% in the middle, then there's 5% left over. One of the things we talked about originally was 100% of the data is underneath the curve. It has a total area under the curve of 1. So if this is 95% in the white, that leaves 5% left over. Confidence intervals are always symmetric, meaning that the 2.5 and 2.5 evenly on the edges gives us our extra 5%. So that missing 5% gets split evenly on the two corners. And it actually makes the problem pretty quick after that. To figure out this data point right there, I have to use inv norm. And we've talked about calculator functions. What invnorm does is it takes an area, or a percentage, an area under the curve, and it will give you the data value or z-score up until that percentage. So it starts at the left. Remember, that's something really important. It always starts at the left, farthest left, and the calculator keeps going until it's reached 2.5% of the data. So for this first point, I'm going to go invnorm on my calculator. The first data value you put in is the area under the curve, or the probability. 2.5 can be represented as 0.025. You can't leave it as a percent. Then you put a comma. After that, you want the mean and the standard deviation. If I don't include these next two numbers, it's going to spit out a z-score. But I don't want that. I want the actual data value. So I'm going to put in the mean next, which is 3,411.72. And then a comma, and I'm going to put in the standard deviation, which is 45.6196, and I'm going to close my bracket. If you actually put that in your calculator, it's going to come out with 3,323.3. So that means that this data point right here is 3,323.3. So that's our lowest left value for this 95% confidence interval. I need the right one as well, so I have to do invnorm again. So I'm going to do invnorm for the right one. The nice thing about confidence interval problems is it's always set up the same with the areas. And because invnorm starts on the far left, always, the calculator starts on the left and goes all the way to the right, you actually need to give the calculator this whole area and have it stop right there. So the actual area under the curve, starting at the far left, going across, and stopping right there, is actually everything but this 2.5%. So from far left all the way up to here is actually 97.5% of the data. So the area I'm going to put in is 0.975, because from far left all the way up to this point right here is 97.5%. Next, then again, I put in my mean and my standard deviation. And it will spit out a data value, and it spits out 3,501.13. So this value here is 3,501.13. Okay? You'll notice it's a written response question. They don't want to give tip-offs to the answer because technically if you found one of the two of these, you're probably going to have an easy time finding the other one. The answer to this question then, as a written response, would be a confidence interval is from 3,323.3 to 3,501.13. That is the 95% confidence interval from here to there.